Here I'm going to show you some examples of how we can use the end behaviors of the sample polynomials, like quadratics and cubic functions, how we can use that to predict the end behavior of any polynomial. So we're going to be using the representative polynomials to do this example. So here's the first example. I have f of x equals negative 3x to the sixth plus 2x squared minus 1. When we look at this is already in the standard form, and we see that this is a sixth degree polynomial with negative leading coefficient. So we can use the representative polynomial function for even degree polynomial, which is going to be the quadratic. And since this is a negative leading coefficient, so we can just draw the quadratic function that is reflected across the x-axis as the representative polynomial for even degree. So in this case, we should expect the behavior of the sixth degree to be similar to this, except that there might be some zeros and so on that is not shown. But generally, the end behavior will look just like this because it's an even degree polynomial. So let's get to it. So we can just see then that as x approaches infinity, which is this side, the right side, f of x is going to negative infinity. F of x is approaching negative infinity. Similarly, as x approaches negative infinity, going to the left side of this function, the polynomial is approaching, is going to negative infinity, is going down. So we can say as x approaches negative infinity, f of x is approaching also negative infinity. All right. The next example, this is also an even degree polynomial, but this time the leading coefficient is positive. So we can use the quadratic function to guide us. The end behavior will be similar to that quadratic that is facing up. So we can say as x, you can see as s is getting larger values of x, the y value is going way up. So we can say as x approaches infinity, f of x is also approaching infinity. You can see it's going up. It's going up. As x approaches negative infinity, as we go to the left side of this function, we can see that the function is also going up. So f of x is also going to infinity. In the next example, we're going to see another example here. Here is 1 minus 3x to the fifth power. Well, this is not in the standard form, so we can rewrite it as 1, as 3, negative 3x to the fifth plus 1. Okay, so that allows us to see that actually the leading coefficient is negative and it's an odd power or odd degree polynomial. So the end behavior will be similar to that of a cubic function that is reflected across the x-axis. So it's going to look like this. The end behavior will be like that. So we can say that as x approaches infinity, see f of x is going to be going down to negative infinity, approaches negative infinity. And as x approaches negative infinity, f of x is going to be approaching positive infinity. So it's going to be going up. So one more example and we'll be done. So it's last example, number 4. F of x equals 3x to the 7th plus 2x minus 6. Okay, in this case, we can see that this is in the standard form. It's an odd degree polynomial with positive leading coefficient. So we can use the regular cubic function to guide us as to what the end behavior will look like. So in this case, we can see that as x goes to infinity, f of x is going to be going up. F of x is going to be going to positive infinity. And as s goes to negative infinity, f of s is going to be going to down in the negative infinity. So no matter what polynomial you're given to analyze the end behavior, you can always use these representative functions to guide us, either a cubic function or a quadratic function to guide you to discover or to find what the end behavior will look like. Hopefully this video will help you a little bit, accept you a little bit. So thanks for watching.